Hello everyone. In this video we see that how to deploy two services in ECS with a single load balancer, and we also add the pipeline and the auto scaling group. This is the first part of the video that we see to deploy two services with a single load balancer with the help of Terraform. Here we go. This is a cluster and this is the name of the cluster dev. Basically, Amazon cluster is a logical grouping of tasks or a service. Your tasks and services are run on the infrastructure that is registered to a cluster. So here is a cluster. Then we move to the data. Data is an exiting service that are available in the AWS. Before moving to the cluster, first we have to create a data that show in console also. Here is first give the permissions for the ECS task execution role policy. Now move to the Terraform. Here we mention the data, then go with security group. Here the security group, this is security group for ECS cluster, and second is this security group SG2. This is a security group for the load balancer. Now move to then common.tf. Here there will be the load balancer, and here this is a target group. The target group tells about the load balancer where the direct the traffic. When creating a load balancer, you can create one or more listener and configure listener rule to direct the traffic to one. Here this is a listener. The name of the listener LB listener. Basically, a listener is a process that check for connection request using the protocol and the port that you configure. And this is a target group. The name of the target group TG1 target group, and we allow the port 80. And this is a listener rule. In this listener rule, here we put the two conditions, that is path pattern and the query string. Basically, the listener rules, the rules that you define for your listener, determine how the load balancer route the request to the target in one or more target group. Now come to the VPC. In previous video, we showed that how to create an VPC, what are the subnets and what are the route tables. And now move to then service 1. This is task definition. Basically, a task definition is a task within a cluster. After you create a task definition for your application with Amazon ECS, you can specify the number of tasks to run on your cluster, and Amazon ECS run and maintain your task. This is a task definition. This is task, and the name of the task is, and CPU we take 256, memory 512. That is the execution role that we show the data. And this is a container. The name of the container Act1 container. This is image that is we push into an ECR. This is our Docker file. We create one Docker file, and there is service, two service. First service in index.html, there is Indian Space Search Organization that we have to show, and the second service is this is Defense Search and Development Organization, and this is single Docker file. And first we push into the ECR, then I show in console also. This is service 1. We have to copy this image URI of service 1, and this is image URI. Then container port is 80. Then ECS services, Act 1 service is the name, and then it cluster. Then a task definition, launch type we had forget, and then network configuration, subnet with a public subnet A and public subnet B. Security group that we mentioned here is security group for the forget, and this is the target group. Target group that we mentioned that AG target, TG target, and this container name, Act 1 container and container port 80. All this will be the service 1 and move to then service 2. Here the name of the task definition task 1 and container name is Act 2 container, that is an image. Then container port 80, then name that Act 2 service, there's ECS service. Then we have subnet, then security group. Here's the target group, the TG1 group, and the container name Act 2 container, and the container port is 80. Now this is service 2, and now we write in command first we write Terraform init, and then Terraform plan, and then Terraform apply. After all this command successful execute, and we move to an console, search for ECS. See, our cluster name is cluster dev. There is 2 services, Act 1 services, Act 2 services. They're running successfully. Now move to the load balancer. As we mentioned that we deploy 2 services with a single load balancer. We show you target group also. This is our target group TG1 and TG group and TG1 group. Click on target. See, our both the status will be healthy. Status and second target group, status healthy. Now move to load balancer. First we see about the listener rules. This is listener rules. See, the first will be directed default, and second we put the path pattern /index.html and the query string is health and check. Now move to the load balancer. Copy this in its name Tested here. Look that our first services is running successfully. Now we run second services index.html. Go to check. Look, our second services is also running successfully. So in this video we shows that how the two services we deploy on ECS and run with a single load balancer. In next video we see how to create a pipeline and autoscaling group. Hello everyone. In this video we see how to create a pipeline and autoscaling group with the help of Terraform. In the previous video we see how to deploy two services with a single load balancer with the help of Terraform. First, we move to the iam.tf. This is code build role. This policy for the code build. The IAM role for the code build. IAM role policy for the code build policy. And this is a pipeline. That IAM role for the code pipeline role. Then IAM role policy for the code pipeline policy. Before moving to the code build part, first we see the build spec file. This is our build spec file. This is service 1, service 2. This is a Docker file. We run two services with a single Docker file. This is build spec file. In pre-build, there is will be login and second build command. First we build, then tag, and the post build we do Docker push and the artifact image definition 1.json, image definitions 2.json. Now move to the code build 1.tf. This code build part is attached with service 1. The name of this code build project is dr_docker_build. This is environment, log configuration S3 logs, and the source type we GitHub, and the location we put es docker to git. This is a link of GitHub. This. Now move to the second service of code build part and code build project dr_docker1_build1. This is for service 2 code build and environment, logs config, S3 logs, source type GitHub, location GitHub UI, GitHub link. Then move to an pipeline. This is first pipeline of service 1. The name is dr_pipeline. The source names source and provider GitHub. Owner third party. The configuration that owner, then name of the repo, branch main, then the token of GitHub, and this is a build. Then move to then deploy. Then owner AWS, provider ECS, input artifact, build output, the configuration, cluster name, cluster dev, service name act1 service. This is ECS service, act1 service. Then file name image definition 1.json. This is pipeline 1 and second pipeline for the service 2. The dr_pipeline1, the name of the pipeline of second service. Then source stage, then move to the build process, then it's deploy, the configuration, cluster name, cluster dev, service name act2 service, act2 service, file name is image definitions 2.json. This is second pipeline, and move to then autoscaling group. This is autoscaling group. Basically Autoscaling monitor your application and automatically adjust the capacity to maintain the steady, predictable performance at the low cost using using Autoscaling group. It easy to set up application scaling for a multiple resource across multiple service in minutes. This is a autoscaling group for service one. The name of his autoscaling is ECS target maximum capacity 1, maximum capacity 4, minimum capacity 1, and the resource ID service cluster dev act 1 service. Then move to the policy. We add two policy: scale up policy and scale down policy. The name is scale up policy. Then service ID service cluster act 1 service, adjustment type change in capacity, and scaling adjustment 1. Now second policy is scale down policy, and we also attach the CloudWatch. The first CloudWatch alarm is name of the alarm is CPU high. This is attached with the scale up policy, and the matrix name is CPU utilization. And second CloudWatch alarm that is attached with the scale down policy. Less than or equal to the threshold, and scale CPU high is greater than or equal to the threshold. The threshold is 80. Here the threshold is 10. And second autoscaling group that is attached to the service 2. The name has ECS underscore target 1, maximum capacity 4, minimum capacity 1. And the resource ID service cluster dev act 2 service. This is autoscaling group. Autoscaling policy. Here we also add two policies: scale up policy and scale down policy, and two CloudWatch alarm CPU high underscore high 1. This attached with the scale up policy 1, and CPU underscore low 1 attached with the scale down policy 1. Now we create an S3 bucket also. Basically the S3 bucket is used to storing the artifact for a pipeline. You can specify the name of an S3 bucket. A folder to contain the pipeline artifact is created for you based on the name of the pipeline. So now we run in Terraform command. The first command is Terraform init, and second command is Terraform plan, and third command is Terraform apply. After all these three commands is successfully executed, now move to console, type code pipeline, now here is two pipeline. The first dr underscore pipeline for the service 1, and second dr underscore pipeline for pipeline 1 for the service 2. On first pipeline, see this successfully executed our first pipeline. We can also check the logs also. This is our code build logs. After the pipeline was successfully executed, it create an artifact. Now move to an S3. This is our S3 bucket, ECS pip artifact that we created, and this is to dr underscore pipeline 1, dr underscore pipeline 1. This shows a folder to contain the pipeline artifact is created for you based on the name of the pipeline. This is two folder. Now we see our autoscaling group. First move on ECS. Cluster dev. Here the click on Act 1 service, first service. Now move to autoscaling group. See, our autoscaling group is also successful created and attached with an ECS cluster of a service 1. Minimum task 1, maximum task 4. Scale down policy, CPU utilization smaller than 10. Scale up policy, CPU utilization greater than 80. Take the action, remove first task when 10 is greater than CPU utilization. Take the action, add one task when the 80 is more than CPU utilization. This is autoscaling group of service 1. This is service 2. Click on autoscaling group. Here, this is autoscaling group for the service 2. Now in this video we see how to create a pipeline and autoscaling group with the help of Terraform.